Welcome back, everyone. If you're new here, my name is Bryan Jenks, and today we're going to talk about SQL. What is SQL? What does it look like? What can you use it for? How do you use it? And just more around it. And if you watch my channel for the Obsidian related content, this is going to carry over to another future video on the data view plugin and how that works using basically query language like SQL. Best ways to support the channel are, if you're going to do it on an ongoing basis, GitHub sponsors because they take no fees, followed by Patreon. If you're going to do like a one-time thing, buy me a coffee, PayPal, or just fine. And if you just want to support me without any money involved, the best thing you can do is like, comment, subscribe, share the video, and that's it. So what exactly is SQL? SQL defined is a domain-specific language used in programming and designed for managing data held in relational database management system, an NA, or for stream processing in a relational data stream, blah, 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 blah. What does that mean? In essence, SQL is a query language to get results and ask questions of your data in a database. So what does a database look like? Is it a piece of hardware? Is it some program that's running somewhere? Is it a file? The short answer is it could be many of those things. You can run a database off of a server, like the thing I got behind me, and that server or that database could be a file, and oftentimes it is a file. And yeah, I mean, there's a lot of ways that it could actually exist. But for the intents and purposes of this video, we want to know what is SQL, the thing that we use to interact with a database, and less on the technical stuff of, setting up a database and what exactly is it, where exactly does it live. And let's take a look at some images here. So when you think of a database, does this type of stuff come to mind? You have some code here, but behind code and behind the actual code that people write, you have these relationships, tables. Like, is this what you think of as a database? Because this is what a relational database is, a relational data management, RDBMS, relational database management system. And what that system is software that usually will help you manage and manipulate and deal with databases. And Microsoft SQL Server uses SQL Server Management Studio, or SSMS for short. And usually it looks something like this. And this is like what we use at work. Anybody who has a Microsoft contract and uses Microsoft SQL Server, you're probably using something like this, or the new Azure Data Studio. But this is what you might see if you either do development against a database, interact with a database, and pull information out of it. You can see here we have these little canisters. A typical representation of a database is this can-looking icon. And you have a database called MS AdventureWorks here. And then underneath this, you have several nested folders. And this is really just to group things visually. You have tables, different schemas for those tables, and wow, lots of stuff. And there's even more collapsed items in here underneath Microsoft SQL Server. There's a lot of stuff in Microsoft SQL Server. And we're going to use that as an example of some of the stuff we're going to talk about today. But SQL itself is the language that we write, the programming language. It's actually Turing complete. It is a programming language. It is a very high level and domain specific language, DSL, which lets you do something very, very niche. It's like, instead of using a kitchen knife to cut everything, if you want to perform surgery, you're not going to use a kitchen knife. You're going to use a scalpel. So this is the scalpel of, for instance, querying or asking questions of your data. And for relational databases, this is when you have tables that have fields that are related to each other. So if you have a person table and an orders table, then the person's ID and then the person's ID on the order table are going to be linked. So because a person can have orders. And that's when you get into relationships. Like, a person is a singular person. There can't be two Bryans, only one Bryan. But Bryan can have multiple orders. So that would be a one-to-many relationship. And this is like the kind of conceptualizing you have to do for a relational database management system, because these database tables relate to each other. And that's how you actually will query your data. You'll say, hey, give me all the people. Now, give me people who have these orders where order ID equals this, or where person ID equals that. So basically, give me Brian's person ID, so where all orders have a person ID equal to that of Brian. And now you have all of my orders, as a very simplistic example. And SQL is actually a really friendly language to pick up because it reads very, very easily like English. And this is like what it looks like. Select c.customer ID, and it does not a lot of obfuscation in here. It's not really super complex. It can be when you start doing a lot of data cleaning and manipulation and all this other stuff and store procedures, blah, 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 blah. It can get really, really crazy. But at the surface level, SQL is a very simple language. It's very easy to pick up, and you can probably pick up the basics of it and how to start working with data easily in a weekend. And hopefully that's what you're going to leave this video with, is just that basic skill set to start using SQL, because SQL is a very pivotal skill if you do things with data and databases, either as a programmer, as a data analyst, a data scientist, data engineer, anything that deals with a database. SQL is going to be your friend, and it helps to know it because a lot of other tools and applications and systems rely on SQL underneath everything to actually get the work done. And it's just fun. So to show you examples from today, I'm going to be using a Docker container that is running a Microsoft SQL server. Now, I'm using this because this is what I'm usually most familiar with and what we use at work, which is Transact SQL, or t-sql as it's commonly known. So what you're going to see is I actually have Docker running, and I have a Docker container running Microsoft SQL Server. It's just running in the background on my system. If you're interested in how I set this up, it's not very difficult. I used this article, and I'll provide the link to it, which kind of just tells you the basics of how to get it set up. And I didn't use all of this, but like once you reach a certain point in here where you have the container running, from that point, instead of doing any of the rest of this in here, I did connect it to Azure Data Studio, which is Microsoft's kind of like VS Code. So it goes on to any platform. So I can use it on Mac, Linux, Windows, and I can use this to connect to database resources to then, work with the database. I actually really like SQL Server Management Studio, but it's only usable on Windows, and I didn't feel like spinning up a Windows virtual machine and dealing with that. Docker was just easier in this case. So what I'm going to be doing is I'm going to be walking through all the examples in Azure Data Studio that is connected to an actual Docker container running Microsoft SQL Server. So that's how we're going to be doing the examples today. And everything, all the code and all the examples and documents and everything is going to be located here. And I will actually be providing that to you, probably either a GitHub link or just something else. But you're going to have access to all this stuff if you wanted to replicate everything that I'm going to show you today. So to start off, what is the actual order of operations of a query? If you're running a query against a database, asking questions of your data, I want to know something. How does that occur? What happens? So I actually have a note in my public notes, and again, link will be provided, that actually lays out the order of operations that occur in a SQL query. You might think that when you first say select something, that it's the first action that you do. Select all from table where condition equals whatever. That's actually not the order of operations. And the more you understand about these types of things that are not visually apparent, the more efficient your querying is going to be, and the better your results are going to be. And you're likely going to get a better benefit. So first of all, the query will say, I don't care about anything other than, first of all, where is it coming from? It's going to say, grab this table. Now, from that point, you're also going to then do all of your joins, your cross applies, your applies, pivots, etc. Any of those operations are the first things that occur. And so what I also like to think about with queries like this is think of your result set. Your result set is, say, select all from table. That just selects everything. Dump the whole table here. Your result set is all of the columns, all of the rows, all the data. So if you take that result set and then do all of your joins on it, if you do a lot of like full outer joins and you just and I'll get into the examples of what the joins are later, but if you just constantly add more and more and more and more data before you do any of your, selecting your where criteria, so where you actually filter through some records to get what you actually care about, you're going to be holding a lot of data, moving a lot of data, and calculating on a lot of data. It grows exponentially and becomes exponentially more expensive. So think of your result set in mind. And this is when things, again, I'll get to example later on, where doing CTEs or common table expressions or temporary tables comes in handy to then just quickly take a small result set and then do iterative joins and calculations upon it, so that your result set that you're moving around into these processes is a lot smaller, more efficient, and lighter weight. But the first step is from. What am I pulling? And you just get all of it. It's just going to grab the table. It doesn't know what it's grabbing yet. It's just grab that table, join these things, and does all the join operations. So more joins, really expensive. So try and keep it small, efficient, fast. And we'll get into how you can do some more of those optimizations later. The second thing is where. So from where. The where is actually where you start to filter your criteria, where you say where this column has this value, or where this column has this date within this range, and those types of things. So you basically say, okay, here's all the data from this table and all the joins to it. The where says, okay, now from all of that, only give me these things. Okay, so now you've filtered your result set. Step 3 is the group by. This is when we start doing some more aggregations. So if you actually had a aggregation function in your select statement, say like a count, and you have a column that just says, let's just say a class, like English or history, and then you have a bunch of these records that just has English history, but then you have a number of students, or just each record is a student and their record of taking that class. Well, you could do a count of students and then group by class. Now you have history 37, English 24, and it would do that aggregation where it starts to combine these results. And we'll get into like specific examples, and I'll show you live examples of all these, so bear with me. That's group by. Now having, this is a very important one, and once you figure out how it's used, it's actually really, really useful. So group by will take your first aggregation, count all these things, group by whatever the class is. That way you can group by a single class, history, English, and just have all of their results gathered into, now you have just 2 line items instead of like 50, whatever. Having is the where criteria, but after you've done this aggregation option. So now that you have English and history with those large numbers, you could say having a count greater than 20 or 25. That would rule out English and keep history, or whatever my example was. So having is really useful for filtering after you've done your aggregation in a group by. So then step 5 is where you actually select what you want from that current result set. You've gotten your tables from, you've selected some stuff from it with the where criteria. You've grouped on whatever aggregation you have, which is in the select statement, but the select doesn't actually process anything yet. But you're going to group by that. Then after you've done that, optional even, having, or you're going to do an additional, filtering on those results of a post-aggregation option. And then from this final result set, select what you want. What do you want from it? What do you want from it? And so that's when you start saying, I want these columns, or I want to select, some text, which then puts it into every column, or however you want to do it. That's when you actually select what you want. Then 5.2, distinct. If you haven't done any aggregation or anything, you can actually add the distinct keyword to then only present unique values. And you can select multiple columns. So it could be, the class, the student count, and then whatever the year is, and select distinct. That way it would only show a distinct year or distinct records where all 3 values are not repeated in a single record. So you could have English 24 and 2002, but then if English 24 2003, oh, that's distinct because those years are different. So that whole line is a distinct line. So it would return both of those. So that's where distinct would actually come in very handy. And it's useful for grabbing a quick list of unique values from something and then using that maybe in another operation. So then that's step 5. Step 6 is order by. Now order by is definitely one of these last steps, because if you have to sort and filter through a bunch of information to then organize it in the output, then order by becomes very expensive. And order by is often counteracted by actually using indexes so that you can actually organize things, and it is structured, clustered index. But then we're going to say, okay, select distinct, I got my stuff, but then the final presentation to the user order it by this column descending, this column ascending, this column descending, and then you can have multiple operations on how you want your data sorted for your final result set. But then, if you have the top option, this is actually going to give you, after sorting, because this makes sense, I want the top, starting from the top, I want this many. Well, if you order it, then that distinction matters. The order of it would matter to when you start selecting the top number of items. So then after you order it and however you want it, if you even order it, top then gets executed and it would return, say, top 1,000 records. That's a common operation when you just select the default values from a table to look at the data, top whatever. And so that's actually the order of operations that occurs in SQL queries. Now, there are differences between PL SQL, t-sql, MySQL, PostgreSQL, all these different versions of SQL, different relational database management systems all use different types of things, and there are differences. By and large, SQL is pretty similar across the board in most things, but there are some minor differences. This and everything I'm talking about is in the context of Transact SQL, t-sql, on Microsoft SQL Server, because it's what I'm used to, it's what we use in government, and if you work in a Microsoft shop, you're likely going to see it. I actually really like t-sql. I've played with PL SQL, I've done SQLite. I'm a fan of t-sql, which is probably one of the few things of Microsoft that I actually like. But those are the order of operations. Now, if you follow my content because of Obsidian and anything I talk about Obsidian, knowing everything in this video and how SQL works is not going to give you some incredibly deep insight into how you can use this with DataView, but knowing the basics of SQL will help you using the DataView plugin. There's a lot of things in DataView that is actually improved by knowing SQL and how to use SQL that you can then move into like other things, because once you start learning regex, SQL, you then really start to unlock a lot of the ability to search through all of your notes and data in general. And it's a very low level investment because SQL is not very hard, not for how much you need to actually be dangerous with it. It's actually a very simple language and you can easily pick it up in a weekend. So if you're interested in getting a little bit more power out of DataView or just learning DataView in general from the beginning, this video will actually help you. So for people who are watching for Obsidian content. All right, so now we're going to get into the specific syntax examples and just more about SQL. So I have on my screen Azure Data Studio. Now, I did actually have to create a database to connect to, obviously. And what that looks like is, if I actually manage this and I need to actually open it up, edit connection. So once you follow that article that I will give you the link to, it was a little bit of a pain to set up a little bit because some of it was confusing to me and I took a long time to get back around to doing this. But once you get the Docker container up and running, then you're going to connect to a new database. And the database, I just say localhost, SQL login, because you're logging in with SQL credentials. And the username is just SA, because that's what it was on the default. And then the password is whatever you change the password to be from that Docker container. And that's about it. I think I also did advanced, did I? No, I did not. Okay, so I didn't have to specify the port. So then that's it. You just have that running on, and the Docker container will run SQL Server on the correct port. So you just say localhost, and it connects to the port where SQL Server is running, and that's it. Connect, and then you are connected. And you can see it's little green over here. This is the database. It's in Docker, but the database connection is live and it's running. Now, if I expand databases, then you can see that, okay, there's two things here. There's a folder, system databases. This is everything that always comes packaged with Microsoft SQL Server, master, MSDB, tempdb. These are all things we don't need to care about those. My examples are in YouTube_test. Now, this is actually data I took from Microsoft's website, and you just run a giant select query and it builds all of this for you. Now, I've built my own databases before and I've built my own stuff for my own applications at work before. So this isn't unfamiliar, and I'll try and find this data for you so you could replicate all of this, but this is a database. A database, in this instance, and for this, the simplistic example, a database is just a collection of tables. Tables, as you can think about them, think of like an Excel spreadsheet or any spreadsheet. columns, rows, and the intersections of those things are the cells. But tables have specific pieces of metadata. A table can actually have many things: columns, keys, constraints, triggers, indexes, statistics. What the heck is all of that stuff? So if I take columns and I expand that, what is this telling me? So this is telling me that we have 4 columns, and this is the column name: course ID, title, credits, department ID. Now there's also some stuff after this: PK, FK, int, not null. What is all that stuff? So if you see PK or FK, you're looking at primary or foreign keys. Now, that's probably a little bit more into database design stuff. You don't need to care too much about that yet, but that's going to help for referential integrity, linking tables together, so I know that courses link to students because students take courses, all of that type of stuff. So that's what keys really come into play with. Int and nvarchar 100, these are data types. This is saying basically this is an integer, and this is a non-variable character 100. So what this means is that it's non-variable, which means you have 100 spots for a character, and if you fill that, then the rest of it, I believe for nvarchar, the rest of it gets padded with spaces or something. But in any case, this is basically a string for what you can think of it. It's text. It could really be anything you want. You could put a number in there, it doesn't matter. And then not null. When you see not null, that means that these fields, when there is a record in this table, none of the fields for that record can be null. If it says null instead of not null, then that means that nulls are allowed to be in this column. In essence, what this is telling you right here at this glance is that you can't have any nulls in this table. There should never be a null field here. Everything should always be filled out if you have a record here. So that's a table in a database and defining its columns. This has columns. Now, if you have keys, we have those primary and foreign keys that we saw earlier, PK, FK. I'm not going to get too into that. Constraints, don't need to worry about that right now. Triggers, we'll get into the triggers later. That's a very interesting and very, very useful tool. Indexes, again, this is going to be a little bit more advanced. We'll get into that kind of thing later, but a unique clustered index is really useful because this will actually sort your output, so you don't even need order by. As long as you know that you want to sort things like this, it's going to take a little bit of an efficiency cost, but overall it's actually going to make using your tables a little bit easier, depending. And statistics, for the sake of this example, you don't need to worry about statistics either. But so that's it. That's a table. A table has data. Now, if I select top 1000 from table, select top 1000, and then all the fields, the names of the fields from that table. Now, this is the database dot schema dot table. Now, the schema, you can see all of these are DBO. Schemas are really useful for organizing your data, and you could use, and I believe a convention is using schemas to say this is where the data came from. So if you have an application that talks to your database, you could say, database.app.table name. That way it differentiates that these are all the tables that are data coming from the application. And then you could have DBOs, which are database object, which is something that only lives in the database. So you can have app stuff, then gets transformed and pushed to a ETL schema, which then transforms into, uses lookups, looking up values in DBO tables, because those exist and only live in the database, and it comes from the database. It's a lookup table. Or use the LKP lookup schema, or any of these things. Schemas you can define your own. But usually it's a good idea to actually use them to organize yourself. But look at the query. We have output. And let's see if we can zoom in a little bit. But we have output. From this table, select, because we don't have any of this other stuff. So the next operation is, so we go from number 1 to number 5, select top, which is number 7, and then we're going to go top 1000, all of these fields. So we're going to select all these fields. So from this table, select all these fields, and now give me the top 1000 of them. And that's the actual order of operations that occurs. And even then, if I run it, it's super quick. Not a lot of data to deal with. So there's only 10 records, so of course it's fast. But this is running a query. This is actually getting data, using data, manipulating data. And because it actually has that unique clustered index, which we can look at it, and it is on, which is that index on? On course. So we can see that course ID School.course unique clustered. I guess it's not on the title, but in any case, we can script as create and we can see what it looks like. Primary key clustered on course, school, course ID. So we can see that, and you can ignore all of this stuff, but basically the index is on course ID. Now, if we look at this, course ID, if I just selected it from scratch, course ID is actually ordered. Not chronologically, but like the values ascend. So 45, 50, 61. So they are actually ordered, and that's because of the index. So I don't have to do an order by course ID. I can just have that index. So that's just a quick example looking at why an index would be important. But a unique clustered index says all these things should be unique, and yeah. So now it's going to order them in the output. So if I insert a new record into the table, it's actually going to look at the course ID and figure out where to insert it. And it basically keeps it always in that ordered state. So, but this is data, and this is what it actually looks like when you select data from an actual table in an actual database. That's it. You just run your first select query. Awesome. Now we can get rid of this because we don't need it. So those are tables. Now what are views? So views are a little bit different. So there's a couple statements here on the screen, and now we're going to create our own view. So there's nothing in here. There's no views yet. A view, and I think that convention is that we don't use views that much anymore. And I forget the exact specifics for but I think some people recommend that not using views because of just how expensive it can be and how much it makes a spider web of the database structure, and just to be better about locking tables and using provisioning. I don't really know. There's always more to learn in this field. But in essence, there's a couple statements here. Go means, hey, everything before me, or everything from me to the last go statement, or basically this whole batch, execute that first, then we continue on. So if I just ran this whole thing, it would do these two batches, first one, then the second one. So I'm going to say, do this operation first, and then what is it going to do? It's going to create a view. What's the name of the view? It's going to be dbo.vw for view course. And the view is going to be these four fields, the same fields from this table. And then this view, what comprises the view? What are we making the view from? So it's going to say this view has these four fields. So currently, if I just ran that, the view has nothing in it. It's just got four fields, four columns, empty, nothing in it. But we're going to create the view as the result of this SQL statement. The SQL statement is select everything from DBO course. So that means this. Everything in this table is going to be selected, but that's actually what's going to make the view. So if I ran this, it actually wants me to re-authenticate there. Okay, I'm going to run it. Commands completed successfully. Now if we expand all that, get to the views, there's the tables, here's the views. Where is that? Where is it? I don't know where it is. Let's refresh. There it is. So if you don't see it, try refreshing. It might be there. But now you've got this view. It's separate from a table. It's different. But here's the columns. Okay, we got all four columns. I'm going to select the top 1000. And what do you know? All the same data. Do we have indexes? Nope, no index. But it still sorts on this course ID. Interesting. And it doesn't tell you anything about keys here either. So we just selected the data. We didn't do any of the database structure. No keys, no constraints, no indexes, just data. Plop it over there. It's in a view. And the reason why you might use views in the database, and skip this if you don't care about the architectural stuff, you might use it because then you can actually select certain columns, but forego adding the personal PII data, the social security number. You can keep it so that it's just, excuse me, so that it's just the information you want to present for, say, a report on the front end for some visualization or business intelligence tool for the business side to use. And that is a very common thing that is done. Now, some people I've heard say don't use views and just use certain provisioning or create just an additional table, maybe use a schema to differentiate it. But just for the sake of example, that is what a view at the surface level looks like, how you might make it, and potentially what you might use it for. But those are different database objects. We got a database, we got a table, we got a view. And that's what we're going to cover for at least that in that respect. All right, now we got some useful knowledge about how a database is structured how it works, and how you might actually get some data out of it. But now we're actually going to look at the specifics of the language. So you saw some basic query language, and honestly, just knowing the order of operations in a couple of those things is like 50, 80, whatever, something percent of what you might need to know to use it. But let's look at some actual examples of the syntax of T-SQL and how you might use this. And this is actually going to get a little comprehensive. I'm not going to go deep into like architecture and setting up all this different stuff that you don't really see, but we're going to look at a lot of different things about the language itself. So let's dive in. The first thing you saw me use before, and I didn't really explain it, was this statement: use YouTube test, that's the name of our database, go. What this is doing is that by default, when you first spin up your database or SQL Server Management Studio and you connect to a database, it's going to connect to master, the master database, which is a system database. It's the default. It will automatically connect to this. So unless you want to say YouTube test .dbo.table and in every single thing, and every time you reference a table, give the full name, unless you want to do that, you can simply just say, hey, the beginning of this query, use this database. That way it always assumes you're using this one. So you can just say, hey, from DBO course, instead of saying from youtube.dbo.course. It's just shorthand and makes it more efficient and simpler. So bam, yes, we run it. Why is it doing that for every time the thing I have open? Okay, completed. We have now successfully connected to this database, and it is going to be the one that we're connected to for any of the queries that we're running. So we can keep this open, but we're going to make it small so it doesn't bother us. Okay, so now a basic select statement. We already saw it. Select everything from, there's the full schema. You can still do it if you want, but select everything from there. We saw this result previously. Now I said top before, top 1000, but this is select star. Star or asterisk means give me everything. Now it is very common convention to basically say, don't ever do that. Don't ever do that. Select top to learn what your data looks like, but then build your selects and your queries to actually be specific and to know what you want. So this is going to be important because if you have a very large amount of data and you're not in a database system that allows you to quit an active query, then you want to be able to make sure that you don't just select everything from a table with millions and millions of records and basically cripple the database because it's executing and trying to gather all that stuff in memory. Because remember, order of operations from give me everything first, then I deal with it. So careful with what you select. So that's the basic select statement. So now select with distinct values. So if we went back to this select and we said, let's look at the titles. Now there's calculus, chemistry, there's a bunch of different things in here. Now, each of these are already distinct. There's no duplicates. Where there are duplicates are in credits. So if I select distinct, now I could just use that to say, hey, give me a distinct list of all unique classes. And it would give me the same 10 records because there are no duplicates here. But if I change title to credits, so this way we're dealing with numbers now, if it would let me scroll. So credits, and an important thing to note in T-SQL, and I think most SQL in general, is that it's not case sensitive. So at least in this one, it's not case sensitive. So this one actually has proper casing. So if I looked up credits with a capital C, this one does not. So casing, not really important in T-SQL, but personally, my preference is to have all keywords as uppercase and use proper snake case for pretty much any names, which proper snake case would be like hello world. That's basically proper snake. So then select distinct credits. So we have duplicates, double threes, double fours, etc. It's going to give you a unique list of those values. So there's only going to be a single number for each of those. And even though there's duplicates, it only shows you distinct. That's very useful for getting a quick and unique list of values. That's distinct. So then select with criteria. So this is where we actually have the where statement working. So we're going to select everything from YouTube course, but only where the credits are greater than 3. So we run that and it gives you this list. Now we could say, hey, show me everything. There's a bunch of stuff that has credits that are not greater than 3. Or was it greater than 3? Yes, greater than 3. So that means 3 is not included. It's not greater than or equal to, it's just greater than. So all the classes with 4 credits, calculus, chemistry, literature, etc. Calculus, chemistry, literature, yes. this is already asking questions of our data. Hey, my next term, I want to take all these high credit courses so I can get a lot of my units done. What are those courses? Select where credits is greater than 4 or greater than 3. There you go, selecting with criteria. So then we go to aggregate functions. So this is what I was saying, where you actually have aggregation, where you can say, hey, select this, but then do something with it, group it, sum it, count it, etc. So these are the bunch of aggregate functions here. We have sum, we have average, count, and oh, hey, what's distinct doing in there? So this is going to be very interesting. And we're just going to run this, and it's going to give us all these batches. Now, this is not every aggregate function. There are more, but this is just what I have included here. So if we run this, okay, by the way, we're doing all of this with credits here, except for when we get to count, we're counting titles there. But so we're saying sum credits. So this is the sum of all credits in the entire table for course. Then we're doing average. What is the average credits? It's 3. Now it could actually be a decimal, but because that field in course columns credits is an integer, it's not a float. So you're not seeing a decimal. So we could say, and this is getting a little bit ahead of myself just because I'm interested in this, cast credits as float. There we go. And we could rerun that and actually see that the average credits is 3.3. So be careful about decimal truncation if you're actually doing an average on an integer field, as an aside. So then we're doing count title, which is basically saying, hey, for each record, count the title, which is really just saying how many records are in the table, unless there were some nulls, but we know there aren't any. So there we go, 10. But then count distinct credits. Okay, well, what does distinct do? Distinct only returns a unique list of something. So distinct credits would return just like that earlier query. Distinct credits is a value of 2, 3, 4. So that's 3 records, 3 rows affected, 3 records. That's the distinct. But then you're saying, hey, count the distinct, which should be 3, right? Oh, hey, 3. Interesting. So the distinct keyword can actually be used in these aggregation functions. So I could say sum distinct credits, and now I only get 9. Why? 2, 3, 4. That's 5, and then 4. That's 9. Total of 9. So it just basically said, give me unique values for the credits. Those 3 numbers, now add them together. That's my result. So that's a little cool trick that when I learned that, I'm like, whoa, that's really useful. So these aggregation functions can actually use distinct inside of them to only do their aggregations on a unique list. That is really, really cool. All right, aliasing new columns. So aliasing, just by definition, it basically means just referring to something as something else. So when we did sum of credits and we got 33, it was just saying no column name. That's odd. Why? So what we can actually do is say as and then add a string. I mean, some people just pass it without the quotes, but I prefer the syntax highlighting to let me know that it's a string, or you should never have spaces in the names, but if you wanted to, you could actually do spaces with having it as a string. But in this case, we're saying, hey, select the sum of credits as total. That's aliasing, saying, hey, the result is going to be named that. So now instead of just being no column name, it just says total. And this also works for just selecting existing fields from a table. So if we actually got rid of that and just said select credits, we could actually just have it say total arbitrarily. So aliasing can change the name of pretty much whatever you want on these fields. Pretty useful skill. Now, let's go down. Date range operators. So dates can get a little funky in SQL. So now we're actually using a different table for this because we need some date information. So if we actually went to the person table, the person table has some dates. If we open up here, so we have hire date and yeah, that's actually what we're using is hire date. So hire date is a date time. Now a date time is not just a date. Now, if you think of like the ISO 8601 dates that I'm so very fond of, where it's year dash month dash day, and then you also have like hours, minutes, seconds, etc. If you actually select a date in SQL, it looks a little different. So I'm actually going to add a code cell. I'm going to say select get date, which is really just saying, hey, the current date today, now. So select that. And here's the value. So we have year, month, day, hours, minutes, seconds, and then milliseconds. So this is what a date time actually looks like, because if we made sure that it's a date time, cast this as date time, and then we run it, same result. That is a date time. So if you're going to do some operations on this, you need to actually cast your dates. So if I only want things that are within a specific year, you want to cast your date to a year or do some other different function so that you can actually pick out that piece of information. Otherwise, things can get a little weird. So just be wary of dates in SQL. So date range operators, select all from this table. So in essence, if I'm reading this in the order of operations, from this table where the date part of year from higher date, so they basically give me the year only from that value, that column. So from this table where the year in this field, the year of this field, is between 2000 and the year of now, today. That's basically what this is saying. And then from that, select everything. Now, again, rereading it, slowly rereading it, from the person table, where the year in the higher date field is between 2000 and the current year. From that result, give me everything. Select that. Here we go. So the higher date, 2002, 4, 1, 1, 2000, 2021, because I actually added this one myself. So this date part year get date is basically saying, give me the current date and then pick out the year from it. So this is basically saying 2000 to 2021. Give me everything from that. And that's date range operators. Between is really useful. And this also comes in handy with the in operator as well. But between, this gives you two values, and this is really useful for doing date ranges because you can easily say that. But because you can actually do this with numerical values, you can actually just use that to say, hey, where this numerical field is between 1 and 100, and it will do that. It'll just pick out all of those instead of having to individually type out each number, which is what you would have to do with the in operator. That does have its purpose. So if you wanted between 2000 and 2021, using between would be better. But what you can do here is you can say where the year from higher date is in this list of values. Now, this doesn't look like what a list you might see if you couldn't do like Python. This looks like a tuple or something. But in essence, from person table, where the year in higher date is in this list of values, 1, 2, 3, select all of them. So running 2002, 1, 1, 2000. There you go. Only the records that match that where criteria. The in operator is a very, very useful operator. We use it all the time. So now we're going to look actually at the grouping results. So we're going to select the discriminator from the person table. So discriminator is just a string. And then the count of discriminator as count. Okay, let's actually look at the data first, because this might just be like, huh? Where did this come in? Discriminator. Okay, I see. By looking at the data and just taking a glance at what I have here before running queries, top 1000, not too taxing on the database. Discriminator is actually the type of person, an instructor, a student, etc. So, okay, we're going to select those values, so all of them, all the students, and then we're going to select an aggregate, a count discriminator. Now, if I didn't have the group by, this would actually throw an error because you're saying, hey, give me all records. So this is going to be like, I don't know, 30 records of just discriminators, student, instructor, student, instructor, whatever. And then you're actually adding a count. But where does that count go? Is every column going to have its own, every record going to have its own count? No, you can't do that. You actually have to group by. So in this case, this is not the aggregation. We're saying, hey, this is the aggregation producing a result, but produce that result for each discriminator because we're grouping on it. So from person table, grouping on discriminator, select the discriminator, and then the count of the discriminator as count. Instructor, there's 9. Student, there's 25. And this one is, you can ignore that. I'm adding that, I added that for something else later. But there you go. That is actually doing a group by operation. Really simple, but this is actually a way of getting some sort of calculations for, say, reporting purposes. Very useful. So now we're actually going to group with exclusions. So from person, grouping by discriminator, having a count of discriminator that is greater than 10, give me the discriminator and the count of discriminator as count. And so you only get student, not instructor, not this one I added, because those are not greater than 10. So that is actually giving yourself results from a group by, but with additional filtering criteria, because we could have added a where clause in here, but instead we just used the having clause to do a filter after the aggregation. Now we can also do organizing our results. So we can say from person where enrollment date is not null, order by the enrollment date, and then give me everything. Everything else that's commented out here, ignore that for now. Okay, so enrollment date, and we're organizing it. So we're saying where it is not null, so it has to have something in it, because enrollment date, see over here, null. This can contain null values. Null values really just means there ain't nothing here. It's not the word null, it's just literally empty space, a void. So where there is not a void, there is something that exists, give me everything and order it. And so by default, the order by is actually ascending. So you can see that this is actually going upwards as we go down into the records. And this becomes even more apparent when I comment that out and uncomment ascending. So this is just explicitly saying how it's being sorted. So if I sort that, the results are exactly the same. But when we take that away and do descending, it's going to say take the most recent one and then go back in time as you go further down. So here's the latest one, back in time as we go down. Now this is actually useful to sort descending. Say from this point, now you're going to select top 1. Well, now you just selected the most recent enrollment for a student, or most recently enrolled student. That's when you start seeing, oh, okay, these really simple keywords in operations, this is kind of powerful. Simple, but powerful. So in that way, you're able to get the most recent enrolled student. But here are some caveats with dealing with null values. So we could just say select everything where not null, and it's a jumble because we're not ordering it. So do not use not equal to null, because this won't work. Because when you do not equal to null, whoa, what the heck? Because nothing can be equal or not equal to null. Null is just null. So this breaks. Then don't use null as a string. We're not equal to null. Again, not gonna work, because first of all, it's a date. But even if it was a string field, this would then return extraneous results, because if it's a string field, it's going to say, okay, well, nothing is equal to the string null, and it never will be, because unless you actually have a string in there of null, it's not going to be treated like a null value, a void. It's going to be the string. So don't do these things. If you're going to test for nulls, you use is null or is not null. And there is a function to test if a field is, in fact, null, and it's just is null. There you go. That's the function. But in essence, if you're going to test for null, use this, is not null. And that's that result. Next, we're going to get into joins. Now that is a very big topic. Joins. Joins are probably the most important, useful, and misunderstood topic in SQL in general. And a lot of people get really confused with joins and how joins work. And you see all these different examples online of Venn diagram images. Joins can be hard, but they're very useful. And when you start to see like how they work, it's okay. That was what I was confused about. What is a join? So a join basically says, hey, take the results from this field, and where these values in this column on table A and these values on this column in table B are the same, do something with it. What the operation is depends on the join. but this is an example. So we have from the person table, and then remember, this is all part of for the first operation is this whole from and joins thing. This is all done first before you select anything. From person, join course instructor, that new table, join course instructor table on, so where course instructor's person ID, where course instructor's person ID is equal to the person ID on the person table. Okay, so what does that do? If we run that, it doesn't change anything, just the output. So then we say, okay, so where they have matching person IDs, joining course instructor onto person, and from that, select everything. Oh, hey, discriminator, course ID, person ID. Interesting. Now we're selecting everything, so this includes everything from person and everything from course instructor where they have been joined. So we have person ID, last name, first name, hire date, enrollment date, discriminator, and then everything else here is course instructor table. Okay, that's why we have two person ID fields. Normally that would not fly, but because this one is actually from this table. Okay, now what if you only want certain columns from a certain table that you've joined onto? So let's actually go to alias tables. So this is actually something useful. Just like the column, when you can alias a column to something else, as credits. What is this C dot here? So if you start doing lots of joins and you're joining like 15 tables, that's probably gonna be really expensive, you need to keep track of which fields are from which table. And that's when you actually use and rely on table aliases so that you know which things came from where. So if I run this, it's exactly the same as before. Course, credits, yeah. The difference is I can refer to this table as C. So instead of typing out youtube.dbo.course.credits, which I'm pretty sure you can actually get away with. Maybe not. No, yeah, you can. As long as you take away the alias, that's functional. But holy crap, is that annoying and a mess. I don't want to have to type that out every single time. So we use aliases like this. So C.credits, so C for course. Keeping it simple so that it actually makes sense and is easy to follow, but also less typing. It can work. So this is how you would actually alias tables when you're doing joins so that it's more efficient to use. So as for the joins, what are they? What are the types of joins? Now, I might have even missed a few. I don't know. There's only a certain few that we really use heavily. Now, join is the same as inner join. It's just you don't have to use the inner keyword, but it's basically the same thing. So basically saying, hey, table A, table B, they have a couple records that match up, but then each one has records that don't match the other one. Inner join says, okay, where they match up, keep those. Everything else, no matches here, no matches here, yeet, get rid of them. So in this case, from person as P, join course instructor as C, on C.personID equals P.personID. This is actually shorter, more concise, more explicit. I broke out the on onto a separate line. This makes more sense. It's clearer. Even if we kept the comments, it's actually clear what this is doing. Okay, same result as before. Now, if I change this out and use inner join, same result. It's the same thing. So that is the inner join. Now, left join, this is one of my favorites. Left join says, hey, the first table, take everything from this table. Where there are matches from table B, tack those on to the ends of table A's records. Where there are no matches and nothing on table B matches to table A, nulls. That's it. So this is really useful and one of my favorites, honestly, because now if we can run this from person as P, left join, course instructors as C, same thing. All we're changing is a single keyword. What type of join? Select everything. So now we get all the things, every record, but now course ID and person ID can be null when there are no matches. So this is a way of keeping all of your original data and only tacking on records where they match from another source. Let's say you're a doctor, you have a patient panel. Here's a list of all your patients, but you want all of the patients who have results for, I don't know, an HbA1c lab that tells you your diabetes, blood value, hemoglobin, A1C, whatever, and join those records to the patient so you can see who's actually had a test. All these patients don't have tests. Where test is null. These patients all need labs. Nurse, go run these labs on these patients. That's the type of stuff that we were actually doing in one of my agencies because we work with healthcare data. That's the type of utility that you get from SQL. And it's pretty easy to use and pretty awesome. Right join. Basically the same as inner join I wrote. So yeah, same thing. But really what this means is the inner join, because you would actually have to match, table B, or in this case, course instructor. So where that one actually matches with the person table, those matches are what is actually saying, okay, so these are the matches. Now these, I want, I exist first, and then join person onto me, but only keep the matches. It's basically the same as the inner join. So why use right if join just works just fine, because it's more confusing. I don't use right join. Full outer join. In essence, this is basically keep everything, and if there aren't matches, put nulls. So both tables where they match, great, they line up. But where they don't match with each other, the other side where they would have values from the other table, all null. So running that. Okay, so we have a bunch of people, nulls over here. Yeah, I mean, now really we have mostly nulls in here and not nulls on this side, because you don't really have course IDs and person IDs or course instructors that don't exist on the person table. You have persons who are not course instructors, the students. So that's why you're not really seeing any nulls on the left-hand side. So in essence, this really is kind of the same result as actually, no, never mind, bad example. But yeah, this is basically keep everything, and where they don't match up, have null. So useful if you want to see the full picture and just where everything matches up. But again, big data, so if you're going to be moving that much data around, you probably want to keep an eye on how expensive that is going to be. And next we're going to get into actual functions. All right, take a breather. Breathe. That was joins. Joins are a lot. So that was definitely a lot to get through. Nice job. Now we're actually going to get into a few more of the language syntaxy type things, the things that really make it possible to do a lot of data analysis, moving stuff around, really getting into the weeds of asking questions of your data, and less of just structuring it to then ask your questions, because a lot of joins in general is really just to get a result set that you then would ask your questions about, or to build something that would then be like reporting data, like select all these records from join this year, and here's all these transactions, now sum up this number, do some calculations, here's my net revenue for this month, or whatever, that type of stuff. So now we're actually going to get into some of the more lower level, in the weeds type things about looking at your data and asking questions. So let's dive in. Date functions. Whoa, that's a lot of stuff on the screen. Okay, let's work through it. Get date. Select get date just says, hey, tell me the date right now. Date and time now. Now, the date part function is really useful because this actually picks out a specific part of the date from a particular date value. It could be a date, it could be a date time. Now, what your result would be from your input, whether it's a date or date time, depends on if this would work or not. But from get date, you get the exact date and time down to the nanosecond. I said millisecond earlier, it's nanosecond. So in essence, like there's also some things in here. Week, weekday, those weren't actually present values on get date, but we can actually calculate them. So in essence, this is just going to select this value, but we're going to get all of the broken out parts. Okay, so let's actually run that. So we got get date, which is the exact date time, year, month, week. Well, it's the new year now, so now it's technically week 2, I guess, according to ISO 86 or the ISO week, whatever. Day is 2, weekday is 1, because it's Sunday, so I have that set that way. Hour is 20. Now this, see, this actually must be based off of some date time that is like UTC or something, because it is not 8 o'clock at night for me. It is actually 1 p.m., not 8 p.m. So this is actually based, I'm guessing, on UTC time. So that means that that's something you need to be careful about. You need to be careful about how these date times and different values are treated like this. Because this is something that actually we ran into at my work, where my application deals with times on something specific, and it's in UTC, which means you want to do some reporting on it and actually deal with some time series analysis. You actually need to pay attention that, oh crap, I need to actually subtract 7 hours from these date values so that they're actually accurate. But then we get hour, minute is accurate, second, I'm sure that's accurate, and then nanosecond, 707, it was just rounded up. That is actually every single value split out. So you can get anything you want from that value, and any date value you pass in here, it could be arbitrary. You could just type in a string of a date or just cast it as a date, and then bam, you're done. That's it. So next we have a whole bunch of these ones. So here's what I was saying. Here's a string, but it's the first part of a date. How does that work? Yes. With dates, because dates have to have the dashes like this, you can actually, it just implicitly casts the data type from string to a date. Just like how you can select a string of a number, like a 1, but in quotes, and then do math with it, totally doable, because it will implicitly just cast that to the correct data type as an integer, because it is. Otherwise, if it wasn't, it would throw an error because it can't complete the cast. So here we go. Date part, year, give me the year of this date, okay? And then cast, here we go, casting the string as a date, casting a date time as a date time, and then casting a date time as a date. Now this is going to be interesting to look forward to, because this is actually going to truncate the values on the end of the date. So basically truncate, it's going to cut those off and say, get them out of here. Date diff, very useful. So using a unit of days, what is the difference between this date and today? Okay. What about it in hours? You can change these units to be whatever, nanosecond, minute, second, weekday, whatever. So going through, and I titled them so you can see which one's aligned to which. So grabbing a year from a string, the year from that string of date, done. Casting a date string to a date, yep. Casting a date time to a date time, or a string to a date time, there we go, done. Casting a date time string to a date, truncates or removes it. The difference of days from the 25th to today is 8, and the difference of hours is that. Now, taking into account UTC time, that hours could be different. The days could even be different. Be careful with date time. And the advice I always got when I was trained with doing SQL is always cast your dates. Cast them to what you want them to be and deal with them correctly. Integer functions. Now, you've already seen some of these in the aggregates, but these are integer functions, things that deal with numbers. Sum, average, give me the maximum, the minimum, and rounding a float value to a particular number of decimal points. And the values are going to be exactly what you would expect. You know, we're going to sum, we're going to average, we saw those values before, what's the highest credits, the minimum credits, and then casting a float value to a single decimal place, which is why you get the 3 instead of the 7 or the 3-7. So it's just truncates there, but it doesn't delete them, it doesn't remove them, it just removes them into zeros. So that's rounding. Now, casting data types, you already saw some of this, but rounding, if we round this, okay, it will give me 1.3. But if we cast the result of this, which is 1.300, as an integer, what do you think is going to happen? It's going to drop everything on it at the decimal, get rid of it. So, but I have a 0.3. What's going to happen? Get rid of it. It doesn't do anything with it. It truncates it because it's casting to an integer. An integer does not have a decimal. But what if we have an integer as a string and we cast it as an int? Yeah, that would work too. Heck, you can even just say, let's see it, select a string of 1 plus 1. Yeah, so we get, the rounding, but then casting it as an integer, you get a 1. And then you cast 1 as a 1, you get a 1. How do we know it's still casting as an integer? Because you can say a string and a number plus together equals 2. Basically the same as Python because you get that implicit data type casting. It's very friendly sometimes, but careful. Yeah, see the example. So be careful sometimes. You don't want to have to rely on that. You want to just have maybe explicitly use the cast function so you know what happens, or just have your stuff already set up to be the correct data type. String functions. This is by far not comprehensive on string functions because there are many, but string functions are very, very useful. And string split is incredibly useful, especially, let me tell you a story about string split. String split is something that I actually had to find out how to get it onto our SQL Server instance at my last job. Because it's very useful. If you have a single column with a bunch of values and they say they're separated by commas, but you only want to have one field for it, so it's not all just bloated everywhere, and you want to actually get all the values for a particular, let's just say, the example was I want to take all the conditions that a patient has, and I want to say, hey, all the conditions are in a single string in a single column. So there's only one record per patient. Split that string and then cross-apply it. So basically, give me a record of everything over here duplicated, or for you guys, everything duplicated over here, but then each condition makes it so it has its own record, but for all the same identical data. Then you could just say where this column, the condition, is equal to this, or is in these values. So in that way, you could just take all the conditions the patient has into a single column, take it out, unpack it into several rows, and then do a where, and then get your information that way. Some might say you might just be better by normalizing the database a little bit more and have separate tables and stuff, but I thought it was a cool thing that you could do. But yeah, so value is, yeah, we'll get there. Select left. So here's the input string and the number. So from my string, starting from the left, I want four items. Same thing from the right. And then substring says, hey, starting at the fourth value, I want 6 items. And then string split. So string split says, here's my input. Here's the thing I want to split on. But then value. What is value? Value is the result of this operation because you're getting multiple items back. You're getting 2 strings back. So value just says, hey, select the value because you're going to get 2 records, which is when you would then cross-apply to the actual main result set to tack them on if you're going to do something like that. But running, so left, you get the first 4. On the right, you get the last 4. And on substring, you get the word string because you start at the 4th one, which is the S, and you go 6 across, which is the full word, and then my string. 2 values because you split it. String split, really useful. I love that function. You can actually have variables in SQL. So here's the actual syntax, is declare, and then the @ a single @ symbol is actually what you use to denote a variable. If you did 2 @ symbols, like @, then it's actually a global variable. Brief intermission. Had to get Starbucks. Pink drink is good. So what we can also do in SQL is we can actually have variables. So variables in SQL are defined by first having a @ symbol. Now, if you do 2 @ symbols, it actually refers to a global variable, and there are several global variables such as @ version, and what that might look like is select @ version, and you'll see I get a little IntelliSense menu. There's several different ones you can get here, and it'll tell you, Microsoft SQL Server 2019, that kind of thing. So there are globals. But when you do a local variable like this, you can say declare myvar, and then what data type? It's an integer. And then you set it, set myvar equal to 1. So if I did that, you can say select myvar and see that it's equal to 1. But, and I'll show you this execution next, you could also just do it all in one line. So declare my new var int equals 1. I prefer that. It's shorter, it's easier, and you can even assign the result of queries to variables even. So we could even say that declare at my final var int equals, and then inside I could say select 1, and that would still work. Like you could select a result set into a variable. And I'm not sure how many, or if it's just a single value, but basically you can set a variable equal to a value. So select at my final var. So we're going to see 3 results and they should all be 1. So if we run all this, all 3 of these are 1. So basically all this works. You can define it on 2 lines, define it, set it later, or just define and set. You can declare it and then set it equal to the result of another query. It's awesome. And they work like this because you can set your variables and then use them later in your calculations. So you can have like a bunch of control options in the beginning of a query. So let's say a whole report runs and you want to have, like, say, sales metrics or something for different states and then different zip codes in that state. And so if you have thousands of zip codes and in the United States, 50 states or whatever, and then you can have all those options. So every single one of those reports run, and you just change the state and the zip code for two variables at the top of the query, and then every other place they're referenced in the query, they're automatically updated. Now, the difference with the thing with variables, though, is variables are transient. So if I go to this second block here and I try to run it, my new var, what? I must declare it. I did. So this is the difference, is once this execution is completed, once I declare my new var and I select it and whatever, and this block is done executing, the variable's gone. It's deleted. It's transient. So it doesn't stick around in some sort of scope or anything. It's defined during the execution, it's used during the execution, and once the execution is over, it's gone. So with variables, if you're going to run them and use them, they have to be selected when you run the code. So in SQL, you can like select things and then hit F5 and just run a particular block of code. I'm not sure if it works in this notebook interface or not. No, it doesn't look like it. Well, select this one, select this code. Yeah, no. So the notebook interface here, not so much. If you did it in here, like I could say select one, and I select just this code and I hit F5, and it would just run this. And that's usually how it works in SQL Server Management Studio. But in the notebooks, not so much. But normally, if you're going to do that and you define a variable, you actually have to have the variable selected with your cursor and the query you're going to run that uses it all at once. So basically, anytime you want to use a variable, you have to execute the code that defines it every time. So it can be annoying, but for setting control options on a query, it's really, really awesome for making your code more reusable, because you can just run those with parameters. So that's really awesome. One really useful thing in SQL is also case statements. So you remember the discriminator from the person table. So we know if somebody's a student or an instructor. So we're going to say from the person table, and we start with next the select. So from the person table, select everything, but then another, so it says select everything. So every column is then returned, but then we're saying comma, okay, oh, another column. So you can actually define and make your own columns on top of just selecting everything that exists from a table. Really powerful and awesome. So we can say select everything, but then also make another column. And this one is going to be a case statement. It's saying, hey, case the discriminator. So we're going to say, looking at the discriminator, when the discriminator is instructor, return a 1 in the field for this record in this column. When discriminator is equal to student, then we get a 2. If it's not equal to either of those, then return a 0. And then that's it. That's the case statement. We're ending it as, and this is going to be the name of the field. And then we're going to order by the case statement. So here's also another interesting thing that comes up. So this case statement is a custom defined field. So nobody knows that this exists. I can't say like where, actually I think I can use in the where clause, but it doesn't exist until I use this. So thankfully the order by comes as one of the last operations. So we select that, we make it, and we define it as this. But I'm not wrapping it in quotes here. Well, you don't have to wrap it in quotes, so this is actually arbitrary. But now that I'm defining it this way and it exists, I can then actually order by that column. So this is a really cool thing. Now, sometimes you run into issues with this when you do aggregators, so sum of something, count it, and then you try to order by it, or do something like that. But sometimes you actually have to like define it twice. So in the order by, you would actually just redefine count of this thing, count distinct, whatever. And that's actually strange, but you have to do that. But in any case, let's run this code. So we can say, hey, here's all the persons. Okay, great. Discriminator, case statement. Okay, this one is a 0 because it's not one of those two. And I define this for something later. Instructor is a 1, student is a 2. And so we defined this new case statement in here. So in this way, this is actually a great way of separating out results easier based on when it doesn't, case discriminator is equal to this. But then you could also do additional case statements for different columns, or make the when case a lot more complex when discriminator is instructor, or have nested case statements when this and then this and then this, or just multiple case statements making multiple columns, and then do a where criteria for where all of the case statement columns are equal to 1 for this particular record. And this is a great way of basically doing like a true-false type of filter when you get multiple case statements set up like this. Lots of ways you can use case statements. Very, very useful coding structure in SQL. But there's also if statements. So we're going to define a variable, and we're going to say declare choice is an integer and then 1. Now, if you're going to do Boolean values, true and false, there is no true and false, but there is a bit field. Bit meaning like a binary bit, 1 or 0, and that's basically true and false. I've seen people use text, varchar, just all caps true and all caps false. It's probably better to just do binary flags with bit, because then it's also less memory used, because you only have a single one bit value, because it's a bit instead of an integer. An integer can go up to like 2 billion or plus or minus values depending on if it's a signed integer or not. But in any case, this is not being used as a bit, but for true and false, use bit. But declare choice, and if choice is equal to 1, it is select all from person. So from the person table, give everything. Otherwise, give everything from the course table. That's if it's 1. If it's 2, then we're going to select everything from the student grades. So this is a way of using an if statement. So in this case, it's kind of also using a guard clause. So we're saying, hey, if it's 1, it is, do this. But if we change it to 2, then saying, hey, if this is 1, it's not, skip it, and then move on. Now, you might notice if you're from other programming languages that there are no braces here. There's not really a great way of doing fencing around any of this stuff. And I believe that it's really just because of indentation is how you denote things are here, or you use begin and end like this if you're going to have like a large block of code. Yeah, I don't really care for if statements too much in SQL, but they're definitely useful. So running this, we can see, okay, yep, this is everything from the person table, because it is. And if I change it to a 2 and run it, then we're not going to get this one. We're actually going to get, we're going to get 2. We're going to get the courses table, because this one, it says, oh, if it's not 1, then else, run course. And if it's 2, equal to student grade. So we get 2 tables. But then if I change it to 3 and then run this, then we only get 1, and we get the courses table, because it hits this else and not either of these 2 beginning options. So those are your basic if statements, and that's kind of basically how you use it. There's not really an else if, I don't think. So you kind of get if, else, and that's it. So some options and more tools in the tool belt. And we do get try catch statements. Now, I personally haven't used these a lot yet, because I haven't done a lot of the like structural coding for T-SQL, store procedures and all that other stuff. I have made some, but I haven't done a lot of like really robust coding for very important data ETL, like financial transactions and medical data. But what you can do with try catch, and I've used these a lot in Python, very useful things. Begin try. So we're going to say, hey, try to do this code. We're going to select 1 divided by 0, which is going to develop or end up with an error. It's going to be an exception because we can't divide by 0. End try. So we are trying the code inside of this block. Now, that's going to throw an error. So what you do is you try to catch the error, which means that you're not just going to like completely just nuke the entire execution. You're going to say, okay, try to run this code. Okay, don't die. But if you hit an error, begin catch. If you hit an error, then do this, end catch. Continue on with your way, but don't just die as soon as you hit an error and run an exception. So in that case, it's going to say, okay, you hit an error, begin catch. Print, I got you, bro. End catch. Run. Yep, there we are, because it caught the error. That's it. If you just try to run this code outside of the try catch and try to run it, probably need to do it beforehand. There we go. It's just going to say, divide by 0 error encountered, state 1, line 3, line 3. It's still going to run the rest of the code in here, but in this case, you can catch it without throwing the errors like that and making it really messy. In my case, it's like it's structured handling of your errors. So try catches, very useful. Definitely add them to your repertoire. A lot of great tools, and this is a lot of the basic stuff that is also present in other programming languages. But SQL has a lot of this stuff. Not many people know SQL is actually a Turing-complete language. You can do a lot more with it than you actually think you can. But it's a very robust and sometimes, depending on how much you use it and how advanced you use it, a very simple language to make some use out of. But now we're going to take a look at some of the more advanced things, more advanced database objects, automations, and really useful stuff that you can get out of a Microsoft T-SQL server. And we're going to take a look at those next. Things like triggers, store procedures, functions, user-defined functions, all kinds of very shiny goodies that can automate and improve a lot of the stuff in your database. All right, so now we're going to start working on the more advanced types of automations and user-defined things that you can get in a SQL server. And there's a lot of really fun stuff to unpack here. Triggers, store procedures, functions, jobs, CTEs, temp tables, all kinds of fun stuff. And stuff that's more along the lines if you're doing actual SQL database work, developing in a database and working in it, and less of the just trying to write some queries. So this is like some of the more advanced, meaty stuff that you do once you dive into databases and that whole realm of things. So let's dive right in. So there are several things we're going to cover. First of all, let's just do functions. Functions, just like any other programming language, you define a function, what it takes in, what it puts out, and you use it, and it's a way of keeping your code dry. Dry being don't repeat yourself, which is a very common idiom in programming. You want to automate things and don't have to rewrite code over and over and over again. You want 50 if statements, just write one function to do something for you, and then just use it 50 times. Keep it simple, keep it concise, and yeah. So functions. First thing we're going to do is we're going to use this database. Now, I'm probably going to make me log in again for this. So let's try and actually add a code cell. And we're going to do select one. Yes, so there. It wants me to log in, so we'll just do that really quick. Okay, now that that's done, we're going to use our database. Then, a very common piece of functionality that is going to be prevalent in this section that I often recommend doing for a lot of this stuff. If it's not transient, like the built-in variables, then you want to make sure you're overriding these things if you're trying to redefine it or something. Instead of just like alter things, I usually prefer to just drop it and then recreate it. There's probably better use cases and explanations for any of that stuff, but in any case, basically, if the object ID of our thing we're trying to define, and it's a function, is not null, so if the object ID exists, then drop the function. If it exists, kill it, so we can remake it. Go. So run that. Use the database, go. Drop it if it exists, go. And instead of delete, it's drop in this case. There is a delete function, a delete keyword for when you're deleting records from a table, but in most cases it's just drop for these objects. Drop the database, drop a table, drop a function. Don't drop database unless you're absolutely sure what you're doing. Then we create our function declaration. Now, the declaration is saying, hey, here's what this function takes in. So create function dbo.do cool stuff. And you can see, oh, hey, variable syntax. What? Well, just wait. Num1 is an integer, num2 an integer. This is the function. It returns an integer. So this is actually really nice that it gives you the typing, so it knows exactly what to expect of types and what it should return as a type. This is very much something that you would expect to see in lower level languages like C, C++, Rust, things where you define the data types. Really useful. Now we create the definition. So we did the declaration, we're declaring what it does and what it takes in. Now we're actually the definition. What is the work it's doing? So returns an integer. This whole thing as, so the function as, and it's going to be this. If you can hear anything out there, I apologize for the noise. But the function is begin, end, so everything inside of this is what the function is doing. We're declaring ret, which is the return value, is an integer because it returns an integer. Select return value equals num1 plus num2, the two inputs. If the return value is null, because one of these inputs is not there, or both of them are null, whatever, set return value to 0. Return, integer, return value. So that way, even if it's null, it still gets set to a 0. So in either case, it is always returning an integer, either a result or a 0. Go. This is saying, hey, now make the thing exist. Then we're actually going to run the function by selecting the results to the output pane, which is select do cool stuff, and we're going to pass in 2 numbers. Now this is where you can start to see some wheels turning here. Oh hey, I could define 2 variables outside of the function, just in the normal global scope. These 2 variables, they're numbers. Pass those variables into the function, and the function then returns stuff like select, or that gets put into another variable, and you start passing around variables, functions, return values, and start building the logic of whatever your query, your report, whatever you're doing. See that logic starting to form there. So now, if we open up the database that we have, okay, I don't see where functions might go. I got tables and I got views before. Programmability, procedures, functions, triggers, all this stuff. I don't really mess with these things, but triggers, functions, and procedures. Functions. So there's a bunch of stuff in here. Oh, hey, I have it in there because I was making sure that this would work, but normally this would not exist in here. So what do? Let's run it. Run the function. Okay, so it successfully uses the database. It successfully drops it. It successfully defines it. And then 1 row affected. We successfully run the code. 1 and 2, it equals 3. That's right. And now here's the function. Do cool stuff, parameters, and this is cool. The function even tells you, breaking down at the top level here in the explanatory pane, it tells you what the functions are and what parameters they take in. A num1, num2, they're integers, they're inputs, and there's no defaults. I'm guessing we could also say, just like when we're defining normal variables, equals 0, and then this number equals 0. So then if we redefine this, and we refresh, because you have to refresh, and we try to break this down, we see it has a default. So instead of saying no default, now it actually has a default value. This is really cool. Help you see your functions. And this type of thing, these drop-down menus, this isn't just Azure Data Studio. You actually get a lot of this type of breakdown and input in SQL Server Management Studio as well. So lots of great info there, lots of great info. So that is functions, and defining your own functions and using those to like contain your business logic, and then putting the output and results of that into another table or a view or some other reporting place away from your raw data tables where your ETL actually lands. Great, great strategy. And next we're going to move on to triggers. Okay, triggers are one of my favorite things because triggers get triggered. So you do something and then it just runs code. And so triggers are really awesome because let's just say I want to create a trigger so that every time there is a new record added to the person table, that it will then change something or do something. And I actually set a trigger on one of my own personal projects at work, is that I have an application I wrote to deal with our ticketing service. And every time a ticket is finished, I have some metrics. It times how long it takes to resolve a ticket, and through the workflow of the application. So once that is done and it gathers that information, it will insert a new record for metric, which is the value of time it takes to do something, into the metrics table, which is just like a bunch of records that then get used as raw data to calculate the reports. And so every time a new record is added to metric, it calls a store procedure. The trigger runs a store procedure, which basically updates all of the reporting tables, which is really just drop table, recreate from the logic of everything that's in the records of metrics. So that way I can calculate the amount of time, minutes, hours, days, all the productivity for using the application for a specific amount of time or a range of time. So we can also do that as a burn down for, this is how many hours of development time it took to make the app. Now here's how many hours of actual work time we did not have to use according to our original timed workflow. So how much time are we saving by using the app? How much time did it take to make the app? And then when do we break even on the investment and payoff of having made the app? And this is some stuff that we're doing at work. And this is all done with triggers, store procedures, and stuff like that we're using in my workplace. And so this is all stuff I've set up in SQL, and it's really, really fun and useful. So triggers. We're going to use the database. If it exists, drop it. we're going to create a trigger on, and this is where it's important. You need to create a trigger on something. Now, you can also do it on a database, I believe. So you can say, hey, if somebody alters the database, do something like logging or back stuff up or whatever. We used to have some triggers in another agency I worked for where it would, if you tried to drop anything, it would keep it as a failsafe, or basically it made it easier to point fingers at who dropped the database. So there's a lot of uses for triggers, but you can say after, and then now what operation, what DML or data manipulation language operation are you trying to get triggered on? I want to, after an insert to this table, an update to the table, or a deletion from the table, I want to run something. So we're going to say after insert. So basically only when I insert a new record into the table do I want to actually run this code. So the trigger on person after a new record is inserted will run this code. The code being update the person table set discriminator equals to triggered where discriminator equals bossman. What does that mean? So what I'm going to do is I'm going to show you first what the table values for person are. And actually, I have a thing to clear this. Actually, I don't think I do. So let's do person table. Select top 1000. Okay. And now what we're going to see is we see, here's one that says triggered. Okay. Now what I want to do is I actually want to delete that value. So we're going to say boop, 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 delete from person where discriminator equals triggered. So I can run that. Okay. And then we can check. And yes, so that value is gone. So now it's going to be more clear when I actually run the example what is actually happening. So when I insert a record into the person table, the trigger will be activated. The trigger is going to say, okay, once you've inserted a record, any record inside the person table that has a discriminator equal to bossman is going to set that discriminator and change it to triggered. Now you can probably already see the result because I just deleted the record from there, but basically insert into the person table these columns. So it's going to align the values to these columns, and basically you just have to give a value for every single column in the table. So usually it helps to right click script as insert. So person script as insert, and it would give you a lot of this stuff as boilerplate, so it's easier to write. So insert into person, the table fields in the parens. Okay, so into those fields, we're going to insert the values, and then inside of another paren, we're going to do this. Now you could also insert multiples by saying values and then doing, I believe you can just do a comma and then do multiple tuples, and it will work just fine. But values of Doe, John, last name, first name, hire date, which is just going to be now, enrollment date, now, and the discriminator, bossman. So we're going to insert this record into the database, but the trigger says, okay, when a new record is inserted, change bossman to triggered. What? So let's run it. Okay, we have inserted a new record into the database. Awesome. So now if I actually ran that code before and select all, you'll see that it's equal to that record. But now, here we go. See the results. From the person table, where the discriminator is in either bossman or triggered, either one, show the results, show everything. Run. Okay, this is the date and time, given for UTC. But now there is no bossman, only triggered, because we triggered the trigger to run. As soon as we inserted that record, insert, runs the code, code says change bossman to triggered. And there you go. We have the results of the trigger. And this is really, really useful for doing things like updating metrics and changing database objects, and the trigger can run any other code. So if you have a large complex store procedure that uses user-defined functions, you can kick off that entire process with a trigger anytime you manipulate a table with any DML event, data manipulation language. Insert, update, delete, all kinds of good fun stuff, and automating a lot of your database stuff. So really, really like triggers. All right, CTEs. Common table expressions. Now, common table expressions are very, very useful because they allow you to cascade your operations into additional operations, but they don't take up a lot of space in memory by defining constant iterative result sets. And that'll become more clear when we get into temporary tables, which are the inverse of that. So what we're going to look at here is a sample CTE. So with my CTE, which is what we're going to call it, is defined as the code within the parens. And so the my CTE is literally just the result of select one as sequence. So the value 1 in the column sequence, single row, single column. Now the comma is what is going to allow us to flow all of this into the next CTE. So second level with parens takes my first one as input. Now I'm not even sure if that is necessary, so we can actually just try it without. And it's not. So what we can do is say this first CTE flows into the second, and we're going to say second is defined as, in the code inside of this, select table alias my CTE as C. So the first one is going to be referenced as C, c.sequence plus 1. So we're basically saying 1 plus 1 as the final result. And then finally, this is just the definition. Nothing happens until you actually select from the last part of the CTE. So select all from second level equals 2 as our result set. And so really the power of this is that you don't have to assign anything, any results to a temporary table, take up memory, put anything anywhere. It's just cascading the operations until it's finally done in the last part of the CTE, which is second level here. So we select everything from the second level because that's where everything is finally landed. I like to think of them as rice paddies, which if you know about rice paddies, like you have a top level and then the water flows down these little hill terraces into it until it finally hits the bottom. And that's basically how CTEs function. You have the top level, my CTE, and then you do something with it, and then comma here at the end, and it flows into the next CTE. Now you can pass them as input, which is what I had with the parens, but it actually causes some weird behavior. But basically you can just say, hey, this is treated kind of like a table because, hey, from my CTE, basically you can treat it as a source result set, which is really, really useful. And we're going to see the inverse in temp tables about why CTEs are actually faster, but also really useful. So temp tables. Now, a temp table actually lives in the system tempdb database. I don't know exactly where they appear in here. You can find them in SQL Server Management Studio. But they're not as transient as variables. They actually sort of stick around for a little bit longer. And this will become more apparent after we run this example. So I'll make a new code cell there so you can see it. Select all from there. So what we're going to do first is we're going to say if the temporary table exists, drop it. If it's not null, if the ID is not null, then drop it. So this is what we do typically with database objects is we don't want to actually use something and then insert into it. Now you have double the amount of records and things get weird. No, fresh start. Drop it if it exists, create a new one. So how you create a temporary table, at least what I'm used to doing, I think you might be able to just define it explicitly. But what I'm used to doing is actually saying select results or select the results of a query into a temporary table. And so what that looks like is saying, hey, from the person table where the discriminator equals triggered, select everything into the temporary table. And then we're going to actually show that result from the temporary table, show everything. And then we're just going to do another operation and we're going to just show how that would look like. So here we go. We're going to select everything from it. It drops it if it exists, selects everything into it, and then actually shows the result. Here's the result. And then 40, 80, yep, so you can actually do some stuff with it, but here's the power. We're in another code cell. Now, if you remember earlier, when I defined a variable and tried to use it in another code cell, it doesn't exist because it only exists during the time of execution. So now if I execute this, it will, in fact, show me that data because the temporary table, hello here, continues to exist and persist at least for some amount of time. I'm not sure how long it actually exists, or if it just floats around forever. I don't think so. If I remember correctly, it's actually time sensitive. But these temporary tables can actually stick around for a brief amount of time and you can reuse them. Now this is a pro and a con because you don't always have to select the entire definition, declaration, drop everything like you do have to do for variables if you want to use them. But On the other hand, if you put something into that table and you go to another part of your query that doesn't expect to have that table at that current stage, like you're supposed to have something else in it at this point and you don't, it can cause some weird aberrant behavior. Really, they are useful, but it's often just, even if it's more legible to do temporary tables, CTEs function cleaner and better, and it just looks a little bit easier to read, just saying, hey, definition of names, but inside an indented paren is just the actual operations and you just cascade them. That is functionally better, even if sometimes the temporary tables look a little bit better and are more iterative. And you might be able to even work around that by saying after the actual first temporary table is used, then select everything from that temporary table, do another operation, and then the results of that operation go into a brand new temporary table, drop the first one, and you can see it already gets to be a little bit more of a headache. CTEs are just really awesome, faster than temp tables, and get the job done. And depending on your preference, I think they're more readable than just doing temp tables and having to hunt down the temp table names. CTEs just make it a little bit more legible. So both are a valid purpose, but I tend to stick with CTEs. All right, this one's going to be a really meaty topic. Stored procedures. Stored procedures in SQL are the secret sauce, the meat and potatoes of ETL and automation. I'm not even going to talk about SSIS. I don't like SSIS. But stored procedures are really awesome. If you have a bunch of functionality, a bunch of code that you want to run and you want to do it on a schedule, or you want to just pass in some values and then have something run, and it's kind of like functions, user-defined functions, but a lot more powerful, this is going to be something that you want to pay attention to. Now, a default is that you want your nulls on, quoted identifier on. I'm not 100% sure what these really mean. ANSI nulls, I think, is just having, you can have null in and it exists, but not sure what quoted identifier means. But moving on. So that's like template stuff. Here's where we actually get into the stored procedure, and this is the drop if exists thing. So if exists, and then this is a little bit more robust way than just defining the exact name, but saying select everything from information schema.routines, where schema equals DBO and and specific name equals, basically, does your stored procedure exist? If it does, drop it. Go. Finally, we actually define the stored procedure. All of that just to get to this. Create stored procedure, or create procedure. DBO, USP, my procedure, as, begin, print, hello there, and go. So remember, we are using the YouTube test database because the very first cell actually had a use statement. But just to be really explicit about what we're doing here, use YouTube test, go. So we want to make sure we're using the database because this actually defines where we're putting the procedure. So we're going to run this. Okay, it defines it, it creates it, but it doesn't actually do anything. It doesn't run it. So now if I go to YouTube test and we're going to go to programmability, stored procedures, drop down, and right here at the bottom, USP my procedure. Now USP is user stored procedure. So what we're going to do is we're actually going to open that up. Parameters. It doesn't take anything because we didn't define any parameters. But you can actually run and script as execute, and we can actually run this stored procedure. So let's do that. We're going to go to the next cell, and here's how you run it. If it takes parameters, and I didn't do anything with parameters here because it can get a little bit messy, but just to keep it clean, what you can do is you can actually pass in parameters by saying exec, the name of the thing you're executing, and then several other fields afterwards, which is the input parameters. And in this case, you could kind of think of stored procedures as another way of just doing a function, but you could have functions inside of stored procedures, and it's just crazy. So you could even pass in whole result sets to stored procedures. It's just, the sky's the limit. So exec stored procedure is just going to run it, and so we're going to run it. Hello there. And that's all it does. That's all it does. Begin, end. It prints that string of text. That's all it does. But where you might actually want to use stored procedures, and where I've used them before, is in like some of my personal projects where a stored procedure I have will run every time I update my metrics table on my app. It triggers, and the trigger runs, and it runs a stored procedure. That stored procedure drops a bunch of report tables and rebuilds them from scratch based on the new data that has been added to a raw data table. So basically, the results of all this data are constantly redefined and rebuilt every time that that trigger runs the store procedure. But what if there's a lull in work and I want to actually have it run on specific set intervals so I have reporting periods as well? Well, that's when you can actually work in jobs. Now, jobs is basically just running a store procedure on a schedule. And so what that looks like is, well, a lot of actually scripted stuff, and it looks like a lot of text. Honestly, it wouldn't make sense, and you don't really, at least I haven't really looked at it from just the code perspective. I kind of just schedule them based on the actual interface, which you can do in SQL Server Management Studio. But basically, all you have to do is go to the SQL Server agent, right-click, make a new job, and then you just type in, basically, the thing you're running is exec my store procedure, and then you just have, you just find the schedule, and you can set some other parameters, and it's all GUI-based. And I don't have a good example of that here because it's kind of a little bit out of scope anyways, but that's when you can actually schedule the operations of running your store procedures versus just doing everything reactively through triggers. But both are very awesome and valid uses of store procedures. And so this is just a lot of the amazing automation that you can get inside of a SQL server. There's a lot of cool things you can do with data. And even though SQL servers are decades old, SQL is old in comparison to like various programming languages. Like in the world of tech and programming, SQL is old, but it's still very simple, easy to pick up, robust, and still has its place. There's a lot of stuff in SQL that makes it very worthwhile of knowing. It's a very easy paradigm to start to grasp. And from there, you actually have a solid understanding about how people structure and use data. And if you want to go further from there, there's a lot of other options like NoSQL databases, MongoDB, people who use YAML as their data storage format, less structured database management systems, different flavors of SQL, PL, Postgres, MySQL, PL/SQL, all kinds of different things, and even crazier stuff like Log4j graph databases. Like there's a lot of stuff in the database realm. It's a rabbit hole of endless stuff, just like anything else in tech. But that's T-SQL in a nutshell. So I hope you enjoyed that foray into the world of SQL databases. And hopefully you found it useful and can apply some of this to some of the work you do either in Obsidian with DataView, databases in general. It's a really great topic. It's a really fun thing to deal with data, and SQL's not that difficult. You don't have to go that deep into it. You can learn what you really need to in a weekend to be dangerous with it. And there's some great careers you can get just by writing SQL and dealing with databases. A lot of fun stuff. So hopefully you enjoyed it. And quick note before we go, thank you to all the patrons and sponsors who support the channel. Greatly appreciate everyone's support. Thank you so much. GitHub is the best place if you want to show your support by using GitHub sponsors because they take no fees. I greatly appreciate all of your support, and I will catch you all in the next one.